Hi students, welcome to Chemistry Online. So in previous class we discussed ionization potential and variation of ionization potential in groups and periods. Then we are going to discuss electron gain enthalpy. Electron gain enthalpy. One more periodic property, it is electron gain enthalpy. Okay, electron gain enthalpy or electron affinity. Electron gain enthalpy or electron affinity is a same E A. Now we are going to discuss what is electron gain enthalpy or electron affinity. Means if you take an atom which is neutral, which is in gaseous state, then if you add an electron to the valence shell of neutral gaseous atom, then some amount of energy is released. That is nothing but electron gain enthalpy or electron affinity. So here I am taking explanation. So here X is a atom which is in gaseous state, adding one electron, then what happened? It can be converts into X minus gas. Here some amount of energy is released. This releasing energy is nothing but electron affinity or electron gain enthalpy. Here delta H equal to negative. Delta H is equal to negative because which is a releasing energy. Then electron affinity is a negative. So it is exothermic reaction. It is a exothermic reaction. If you add one more electron, that is endothermic. Instead of releasing energy is absorbed. That is also electron affinity. Sometimes electron affinity is positive, sometimes electron affinity is negative. Electron affinity is a positive, means that is endothermic reaction. Electron affinity is a negative, means that is a exothermic reaction. So here variation of atomic variation of electron affinity. So what happens in period and what happens in group, we are going to discuss. First one, in period. So what happens electron affinity in period means, if we move from left to right, then electron affinity increases. Electron affinity increases due to decrease atomic size. Due to if we move from left to right, then electron affinity increases due to decrease atomic size. due to decrease atomic size. It is in period. Okay, periods we move from left to right. Then what happened? Electron affinity increases due to decreasing atomic size. So atomic size decreases means electron gaining enthalpy increases. It is in period. So in group, so if we move from top to bottom, T for top, B for bottom, top to bottom, then electron affinity decreases. Electron affinity decreases due to increase atomic size. Due to increased atomic size. Here you have to know a note. In the periodic table, highest electron affinity value having element is chlorine. Highest electron affinity is equal to chlorine. That is nearly minus 349 kilojoules per mole. Minus 349 kilojoules per mole. This is for highest electron affinity value having element is chlorine. Understand? This is briefly electron affinity. What is electron affinity means? The amount of energy is released when an electron is added to a neutral gaseous isolated atom of valency shell. Valency shell of neutral gaseous isolated atom is called electron affinity, which is measured in kilojoules per mole or kilojoules per atom. Then next one is electronegativity. Electronegativity. This is EN. What is electronegativity means? The tendency of attracting sharing electron pair towards its nucleus, towards nucleus of the one atom is nothing but electronegativity. For example, X and Y two atoms. Here, for example, X is a atom plus Y gives rise to X, Y. Here one electron pair is mutually shared, and then this electron pair is pulling towards one atom. So the electron pair is pulled towards one atom's nucleus. It is called electronegativity. The tendency of pulling electron pair towards one nucleus of atom, is nothing but electronegativity. See here, variation of electron, the tendency of pulling electron pair towards its nucleus of an atom is called electronegativity. So here, variation of electronegativity you have to know. Variation of electronegativity. First one in period. First one in period. In period, if we move from left to right, if we move from left to right. Then what happened? Electronegativity increases. Electronegativity increases. In period, if we move from left to right, electronegativity increases. Due to nuclear charge, due to nuclear charge increases. Due to nuclear charge increases. Nuclear charge increases. Okay. So here if we move from left to right, electronegativity increases due to nuclear charge increases. Then in group, if we move from top to bottom, T to B means top to bottom, electronegativity decreases. Electronegativity decreases due to decrease in atomic size, or due to decrease nuclear charge, due to nuclear charge, increase in nuclear charge, or due to decrease nuclear charge. This is in period and it is in a group. So electron affinity and electron negativity are both are same. Electron affinity, electron negativity both increases in period, both decreases in group. This is periodic property. Fourth one. So first one is atomic radius, second one is ionization potential, it is a third one, and it is a fourth one. Okay. So what is electron gain enthalpy means? Electron gain enthalpy or electron affinity is same. When an electron is added to neutral gaseous isolated atom, that can be converted into uni-negative ion. This can be converted into uni-negative ion, and then here some amount of energy is released. The releasing energy is nothing but a negative, so it is a exothermic reaction. Then variation of electron affinity in period. If we move from left to right, electron affinity increases due to decrease in atomic size. Here electron affinity decreases due to increase in atomic size. Here highest electron affinity value having element is chlorine. And then one more note you have to know here, highest electron negativity having element is fluorine. Highest electron negativity having element is fluorine. Here I am writing a note. Highest electron negativity equal to fluorine, that is 4. Highest electron negativity in the periodic table equal to fluorine, that is 4. Highest electron negativity is chlorine, that is okay. Highest electron affinity is fluorine, highest electron negativity is fluorine. 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 It is a chlorine. 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 Okay. These two are important points. It is nothing but electron gain enthalpy and electron negativity. Understand? Then we will discuss nature of oxides. Nature of oxides. Okay, students. Next, nature of, it is fifth one, nature of oxides. Nature of oxides. Nature of oxides. Nature is two types. So first one is acidic nature, acidic nature, and second one is basic nature. Okay, so acidic oxides dissolved in water, metal oxides dissolved in water, they form bases which having basic nature. Non-metal oxides dissolved in water, they form acids which is nothing but a acidic nature. Okay, so here first acidic nature. Acidic nature. Okay, metal oxides, non-metal oxides plus water, non-metal oxides plus water, which gives rise to acids. Okay, means next, second one, basic nature. Basic nature. See, metal oxides plus water gives rise to bases. Example, first A, second A. Here example, 6th A, 7th A. 6th A, 7th A groups here, first A, second A groups. Now variation of nature means variation of acidic nature and basic nature in groups and period. Variation of nature of oxides. Variation of nature of oxides. Okay, in period first. In period. What happened nature of oxides in period? Okay, if we move from left to right. So left to right, basic nature decreases. Left to right, basic nature decreases. Okay, acidic nature increases. Acidic nature increases. Okay, then in group, if we move from okay, from T to B, means top to bottom, what happened? Basic nature increases, and acidic nature if we move from top to bottom, basic nature increases and acidic nature decreases. Acidic nature decreases. Okay, this is variation of nature of oxides in groups and periods. So it is a basic nature and it is a acidic nature. Then here it is a basic nature, here it is a acidic nature. Okay, then this upward symbol indicates increasing, downward symbol indicates decreasing. So if we observe nature of oxides in third period, so what happened? So here nature of oxides in third period, nature of oxides in third period. Okay, here I am taking atom, next oxide, its nature. Okay, atom, oxide, its nature. Atom is third period elements. Third period elements. What are third period elements? Atom, sodium, magnesium, next aluminum, next silicon, next phosphorus, next chlorine. Okay, so these are third period elements. Okay, atoms. Okay, sodium can form oxides Na2O, magnesium can forms MgO, aluminum can forms Al2O3, silicon can form SiO2, phosphorus can form P4O10 oxide, chlorine can form Cl2O7. It is a strongly basic. It is a strongly acidic. Okay. It is a weakly basic. It is a strongly acidic. Okay. It is a amphoteric. It is a amphoteric. It is a acidic. Okay. So what I mean to say, basic, weak, amphoteric. Amphoteric means 50% acidic nature, 50% basic nature. It is acidic. It is a strongly acidic. Means basic nature increases in the period. So acidic nature decreases in the group. It is a period, it is a group. Only here third period. Only it is a third period we are observing. But in the same pattern will be exist in periods and groups. This is nature of oxides. Understand? Nature of oxides means acidic nature, basic nature. So acidic nature, basic nature. Acidic nature, non-metal oxides dissolved in water, which gives acids. Non-metals means 6th A, 7th A. It is a first A, second A. It is a third A. It is a 4th A, 5th A, 6th A. It is a first A. It is a second A. It is a third A. It is a fourth A. It is a fifth A. Sorry. It is a fifth A. Then sulfur also we have to take. Sulfur. So silicon, phosphorus, sulfur, chlorine we have to take. So here 6th A. 6th A and 7th A. Okay. Okay. Here 6th A sulfur, 7th A chlorine. Sulfur can form SO3. Okay. Next it is strongly acidic. Strongly acidic. It is a Cl2O7. It is a strongly acidic. Here it is a acidic. Here it is only acidic. It is a weakly acidic. It is a weakly acidic. So it is 6th A, 7th A and 8th A. Okay. So this is nature of oxides in third period. First A, second A, third A, fourth A, fifth A, 6th A, 7th A. 6th A, 7th A. Then it is the nature of oxides. Okay. Then we will discuss some more topics in this chapter. Diagonal relationship, next lanthanide contraction and valency. On discussing these topics, we will finish periodic table, which is 8 marks. Got it? Good boy.